So you have decided to use a supercomputer to work with your data analysis or simulation faster and more efficiently. In this video, we will discuss one of the most frequent questions we get. How does accessing a supercomputer look like? We will run a simple program using Lumi, one of the fastest supercomputers in the world and also one of the greenest ones. It's up here in Finland. By the way, did you know that all the excess heat produced by Lumi gets wired into saunas in Kajaani for Finnish people to enjoy? True story. More seriously, the Euro HPC Joint Undertaking has put a number of supercomputers in multiple European countries, and companies and public organizations in Europe are eligible to access them for free. If you don't know how, check our previous video. Some disclaimer, different supercomputers have different procedures, so remember to consult the documentation and the system admin team once you get access. You will also need some basic understanding of Unix shell commands. So let's say I got my access on Lumi. Then what? First, I have to authenticate my computer. This is done by generating SSH keys on your terminal, regardless of your operating system. There are a few ways you can do this, but for the sake of this video, we'll use the following command. This generates a 4096-bit RSA key. We could customize the name of the keys, but for now, we'll stick with the defaults. We choose the password of our choice and move on. We can see that a folder with the name SSH has been created in our home folder, with a pair of SSH key files. When we access the folder, we see that one is called IDRSA and the other one idrsa.pub, which stands for public. The public file is the one that you're going to be sending to the supercomputer for your identification. You can see the contents of the file using the command cat and then the name of the file. And as you can see, it is a text file containing a string of letters and digits. In the case of Lumi, you paste the text in My Access ID, which is the login system Lumi is using. Remember to just share your .pub file and not the other one, which must be kept private. One thing to remember is that the computer that you generated the SSH keys with must be the one that you will use for accessing the supercomputer. To use other computers, you will have to regenerate the SSH keys on that computer using the same procedure and upload the new .pub file. And in a couple of hours, our computer will be authorized to access Lumi. Let's log in. We type SSH-I. The I flag means that we will use an identity file to log in, and then the path to the private SSH key on our computer, followed by the username that Lumi has provided us with. And we are now logged into Lumi. We can also see relevant information regarding documentation and user support, along with important announcements. By typing pwd, we see that we are located in our user folder. We also type ls to list all the files, and we can see that the folder is currently empty. We have a hello.py file on our desktop, which prints a greeting and the current date and time. To copy it to the supercomputer, we open a new local terminal instance and type the following. SCP stands for Secure Copy and copies our file, which is currently on our desktop, to our user folder address on Lumi. Typing ls on the Lumi terminal, we see that our file has now been transferred to Lumi. Before we continue, it would be useful to explain how a supercomputer works. Let's talk nodes and partitions. The moment you log into a supercomputer, you are accessing the login node. This is the first point of access on a supercomputer. The login nodes are for administrating your jobs and not for running computations. The compute nodes are nodes that are supposed to be doing all the hard computational work, and you need to access those in order to run your jobs. You can imagine each node as a separate computer, like a powerful workstation but without the screen and keyboard. Each node is connected to other nodes with a high-speed network inside the cluster. You can reach the full potential of a supercomputer by accessing multiple nodes and run your jobs in parallel. That is why it's often called parallel computing. Partitions are groups of nodes that are reserved for a specific use. This helps you and the admin team with node availability and structuring your work, because multiple users will have access to the supercomputer simultaneously. To have a view of the partitions, we write sinfo-s, and we see all the different partitions with the availability numbers and other info. Depending on your work, you may choose different partitions accordingly. You can access the compute nodes in two ways, interactively via the salloc command and non-interactively through batch scripts. salloc gives you direct access to the number of the compute nodes that you specify. Usually, it is used to quickly reserve a few nodes when you want to test, verify, or debug your code. For instance, let's say we want to access one compute node with salloc to debug our code. We write the following. This command will book one node for 30 minutes on partition debug using our project number that we have on Lumi. With the command sq-u followed by your username, you can check which allocations you currently have. At the moment, we have one node allocated to us through the previous salloc command. Okay, now that we have allocated a node for our project, let's run a test job on Lumi. We now need to load a Python module to run the file because at the moment Lumi doesn't know which programming language or software we're going to use. To find out what Python modules are available, we type module avail python. Let's choose the first one and load it by typing module load and the name of the Python module. Now Python is loaded and we can run the file by typing srun python and then the name of our file. With srun, we use the compute node that we have allocated for our jobs using salloc, and we immediately see the output of our program on the terminal. Let's now talk batch scripts using Slurm. Slurm is a job scheduler that helps with, well, scheduling your jobs once the number of compute nodes you specify becomes available. To use Slurm, we create the batch file by typing the following: nano, and then the name of our choice for the batch job. In this case, we name it batch_job.sh. We can use any text editor we want, but for this case, we use nano. A simple batch script can look like this. In the top, we have the name of the batch job, the output file where we're going to save our results, and an error file that contains possible run errors. We also see the partitions that we want to use, in this case standard, the node number that we need, the time of the allocation, and the project number. The script will run the same file as before once the 4 nodes that we specified will become available for the time that we entered. So now we are set to run the batch script. We type sbatch and then the name of the batch job, and whenever Lumi has 4 free CPU nodes, our batch job will start. Because the batch was very simple, we can already see the results. We see that our file has been run 4 times because we used 4 nodes in parallel and didn't specify any form of parallelization. And there you go, we have now run a simple Python program on Lumi, one of the world's fastest supercomputers, for free. And it's now your turn. Do you need more computing power for your projects? EuroHPC has got your back in every European country for any type of supercomputing support, from training to hands-on consulting. You can find all info in the description below, so don't hesitate to contact us for any questions.